load section there, and we push enter. And then we always ask you to air and ground balance every time you load that program, because the ground's going to be different in different places that you use it. So I hit enter on the air balance and enter on the ground balance. Now that program is in there, and I remember that I turned on VCO, so just to check and make sure that's my program, I'll squeeze the trigger and see if VCO is on. And it is. So we know that we're in Randy's Relic program now. And that's basically all there is to saving and creating a custom program.
The DFX is the latest in a long tradition of American-made excellence from White's Electronics. Headquartered in the heart of the Pacific Northwest, the factory in Sweet Home, Oregon produces a combination of handcrafted perfection and cutting-edge technology, which is one of a kind.
For over 50 years, White's Electronics has been building metal detectors from scratch right here in our Sweet Home, Oregon factory. Custom tools are designed and machined in-house by our tool and die makers. Raw materials are used to construct the durable quality products our customers demand. White's uses processes and materials proven over the years to produce a high-quality product that performs where it counts, in the field. Parts and materials are handcrafted in-house and tested every step of the way to assure quality. Automation is used when it provides an increase in quality and/or performance. Each and every detector is put through a series of rigorous engineering specification tests to assure it performs to our customers' high standards.
As you might expect with a high-quality device, there comes with it a solid warranty. You'll want to learn more about that from your local dealer, but rest assured, once a detector leaves the plant in Sweet Home, it's expected to provide many years of reliable, trouble-free performance. In the event that your detector does fail, contact your dealer. There may be a quick, simple fix. Make sure to check the obvious, such as batteries, and you might want to try your detector in another area just to be sure interference isn't the source of your problem. For the authorized service center nearest you, contact your local dealer. We want to leave you with a few words about the code of conduct while you hunt in various locations. If you're new to this fascinating hobby, common sense will usually keep you on the right track. For example, if you wish to hunt on private property, be sure to get the owner's permission. More often than not, they'll be more than willing, as long as you take care to leave the property as you found it. Close gates behind you as you enter fenced areas, and always pick up trash that you find on or in the ground. If you plan to hunt public property, be sure to check with your local government to make sure it's permissible to metal detect. Now you're ready to do some treasure hunting. To learn more about techniques from the world's best treasure hunters, consult your local dealer. There's many resources available, including books and tapes. Ask your dealer about any accessories you may find helpful. And last but not least, get out there and enjoy your detector. Nothing will make you a better treasure hunter than hunting for treasure.
In order to understand what the DFX is capable of, it's probably useful to start out by talking about what happens as we change the transmitter frequency that we use to interrogate the target in the ground. I'll draw a phase diagram, which we frequently use to indicate signals. And for reference, I'll indicate the targets as they show up on for example, on an XLT or one of our machines that runs at 6.6 kilohertz. The ferrous ground normally shows up in this region. Salt would come in about here, and silver dollars would come at this far end of the scale. And I can put VDI numbers on here to further indicate what these signals indicate. This would be approximately minus 93, approximately plus 5, and about plus 93. And again, these are the numbers that you would see on a machine running at 6.6 kilohertz. Now, if I change the transmitter frequency down to 3 kilohertz, these signals are going to move a little bit. The dollar will come back this way to maybe 80 or thereabouts. Salt will move in this direction and will get considerably weaker. But the ground, fortunately, will stay about the same. If I go to a higher frequency, let me indicate here that the red indicates 3 kilohertz. If I go to a higher frequency, like 15 kilohertz, the salt is going to move in this direction, and the signal may get stronger. The silver dollar will move even farther down in this direction. And once again, the ground will stay in approximately the same spot. So what I can do is I can plot a line that shows the general trend in which targets move as the frequency is changed. I'll indicate that like so. So what happens is that as we increase the frequency, the target is going to move out in this direction, and eventually all targets will arrive in the area where silver dollars normally fall. Okay, next, I think I'll clean this diagram up a little bit and talk about what happens with a particular target as you change the transmitter frequency. I'll use a nickel just as an example. If I go low enough in frequency, let's say I was to go down to maybe 500 hertz, the nickel might appear down in this region. And the length of the arrow that I draw indicates the strength of the signal. And you can see that at a very low frequency, that target will be very weak. Now as I begin to increase the frequency and go up to, let's say, 3 kilohertz, I get a stronger signal, and the phase begins to move out in this direction. If I go up to 6.6, I might be in this region. If I continue to increase in frequency, the target will move out along this line. So what you can see happening is that as we go up in frequency, the length of the arrow that I've drawn gets longer, indicating that the strength of the signal is increasing. But there comes a point where the signal really doesn't get stronger anymore. It merely rotates in phase until it hits this limiting point right here. And that's important because the ground that we balance to is along this axis here. And we want to keep that signal back away from the ground so that we can easily tell the difference between the ground and the targets that are buried in it. So the optimum frequency to pick for a given target is going to be the one at which the signal is strong, and yet it hasn't begun to approach the ground axis where we have a difficult time telling the target from the ground. So for example, for a nickel, 15 kilohertz might be a really good choice. But at that frequency, a dollar might be clear over in this range, and we can gain something on the dollar by bringing it back this way by going to a lower frequency. So 3 kilohertz will be a very good frequency for dollars. Now another interesting thing that happens, I'll clean up my diagram again, but as we go up in frequency and targets begin to move out in this direction, if I were to go high enough, all the targets that I care about will get pushed together at this end of the scale, and it becomes very difficult to separate them out and tell one from the other. The same thing happens at this end of the scale. If I go low enough in frequency, all the targets that I care about will get compressed in this range, and once again it becomes very difficult to separate them out. But if I can pick a more appropriate frequency, I can get these targets to spread out. We'll change colors again here. For example, at 6.6 kilohertz, we get a nice spread between nickels, zinc pennies, silver dimes, and dollars. And one of the advantages of going to a higher frequency is that targets such as rings and small gold jewelry items that normally fall in this range will begin to spread out, and it becomes more easy to separate them and tell one from the other. You get better discrimination on targets in that range. By the same token, if I go lower in frequency, my copper and silver coins and targets in this range will begin to spread out, and it becomes easy